Hello student, welcome to the Score Booster series of ACE Engineering Academy. I am Ravi sir. I have the total teaching experience more than 14 years. I am in teaching field from 2011. Here I am teaching the production subject, manufacturing subject, and today in this session I am solving some multiple select question as well as numerical answer type of important question of GATE 2026. Okay. Now guys, I am going to cover here the fourth chapter, the casting, welding, advanced machining method, non-traditional machining method. Now I am starting with the first casting question here. Guys, here you can see that this is the multiple select question. You can see it here. Allowance, or in bracket you can see that the S is written, that is allowances provided on a pattern for easy removal from the sand mold is. Guys, the two allowances are specially for easy removal of pattern. Okay. For easy removal of pattern, we have to easily remove the pattern from the sand mold, and for that the two allowances are there. One is the draft allowance is here, you can see the draft allowance, and second is shake allowance. Okay, you can see both allowances here. You can see here the shake allowance, you can see by shaking, this is the pattern you can see, and by shaking we are removing the pattern, and if we are doing the shaking, then what happened, the size of this mold is going to increase. Now just I want to write the dimension, just consider that here the size is 10, just we are taking 10 number, but because of shaking here you can see that shaking means here is the spike and we are holding the spike. We are holding the spike and we are giving some forces here, and because of here this size is 10, and you can see that this cavity size here, you can see that this cavity size is going to increase, and this is known as shake allowance. Then guys, because of that we can easily remove the pattern from the mold. What is the question here? Allowance is provided on pattern for easy removal from the sand mold. We have to remove the pattern from the sand mold, then the shake allowance is there. And guys, that shake allowance is also known as wrapping allowance. What I am saying, the shake allowance is also known as wrapping allowance. Okay, this allowance is also known as, this is the shake allowance. I am writing here, this is the shake allowance. Okay, this is one answer. The second answer is draft allowance. Now see the diagram of draft allowance. Now here is question, what is the draft? This angle is known as draft allowance. Here you can see this angle is known as draft allowance. This angle is known as draft allowance. Draft allowance. Yes. Now here you can see that when we are going to lift that pattern, some gap is going to form here. You can see that here some gap is going to form, and because of gap there is no friction between this mold wall and pattern wall. Which is the mold wall? This is the mold wall and this is the pattern wall, and easily we can remove the pattern from the sand mold. Therefore, which is the correct answer here? The draft allowance. And guys, the draft allowance is also known as taper allowance. Here you can see that these draft allowance is also known as taper allowance. Then answer is shake allowance is the wrapping allowance and draft allowance is also known as taper allowance. Therefore, correct option, three options are there: option A, option B and option C. Next one, option D, you can see that the distortion allowance, guys. The distortion allowance is not used for easily removal of pattern from the sand mold. Okay, yeah, as you know, there are total the 5 type of allowances. First is shrinkage allowance, the second allowance is machining allowance, third is draft allowance or taper allowance, fourth is shake allowance or wrapping allowance, and fifth one is distortion allowance. But here the correct answer is A, B, C. Okay. Now see the next question here. Yeah. Pouring time in a casting decreases by increasing the following parameter. This is, guys, not easy question. This is somewhat tough question. You also try to give the answer here. Okay. Pouring time in a casting decreases by increasing the following parameter. Firstly, I want to write the formula for pouring time. Then I am writing the pouring time formula here. Pouring time. What is the formula for pouring time? Here it is volume divided by area into velocity. Okay. Then pouring time in a casting decreases. Means pouring time in a casting decreases. When the pouring time will decrease, when the velocity is going to increase. Okay, is there option velocity? By increasing the falling parameter. Correct. The velocity is correct. When velocity is going to increase, then you can see that the pouring time is going to reduce. It is correct. One option is correct. That is option B is correct. Okay. Next guys, what about the fluidity? What you think about the fluidity here? Guys, just see the fluidity means what? Fluidity means the fluid can flow very fast. Which are the fluid? Liquids and gases are the fluid. Here which fluid we are using in the casting chapter? The liquid metal we are using. Means as the fluidity is going to increase, it means that the liquid is moving very fast. Liquid is going from one position to other position very fast, and therefore the liquid is moving very fast. It means that the velocity is more, therefore the fluidity is also correct answer. Therefore here B and C are the correct answer. B and C are the correct answer. Okay. But what about the area? Guys, area is constant here. Area is constant. Which area we are taking? Either area of sprue or area of runner or area of ingot. The minimum area we are taking. Okay. Next is what? Viscosity. Next is what? Viscosity here. Okay, what about the viscosity? Guys, it is not easy. It is some tough concept of viscosity is there. Then how we can tackle with that viscosity? Okay, how we can tackle with that viscosity? Okay. Then guys, as the viscosity is more, fluid is more thick. If viscosity is more, I am writing here viscosity. City is more, then fluid is thick. And if the fluid is thick, then it cannot travel fast, because there will be the more friction between the surface and that fluid or that liquid. The friction is more. If the fluid thickness is more, then when the fluid, means when the liquid is traveling over the surface, then the friction is more between that liquid and surface, and because of friction, what is going to happen? The velocity is going to reduce. And if the velocity is going to reduce, then the pouring time is going to increase. Very important concept is here. And here the viscosity is also not correct option, then correct option is B and C is the correct option. Yeah, next question here. This is also, guys, very important concept here. During solidification of pure metal, grains at the center of casting is R. Grains at the center of casting. Now guys, this is the mold you can see. This is mold, means where is the mold? Here the total is the mold. Here this is the total is the mold. And here you can see that the diagram of casted component or casting cavity you can see. Means mold is up to here. Yes, the mold is up to here. You can see the mold is up to here. This is total mold here. Okay, this is total mold is here. And this is the casting cavity, and in that casting cavity we pour the molten metal. We pour the molten metal. When we pour the molten metal, then what is going to happen here? The mold wall is going to convert into solid very fast, because the mold is at room temperature. Therefore, here you can see that the small grains are going to form. But what is the question? Is they are asking what the type of grains are going to form at the border of that component or the border of casting? No, they are asking during the solidification of pure metal, grains at the center of casting. They are asking grains at the center of casting, and here you can see that grains are column-like grains. Here you can see that the grains are column-like grains are going to form at the center of casting. Then here I am saying these are the columnar grains. Columnar grains. That column-like grains are going to form here. That is, the columnar grains are going to form. Is the option columnar grains? Correct. Option B is there. Okay, but here it is written is or. This is the multiple select question here. Columnar grains is the correct answer. Okay. Okay. And that columnar grains are longer grains. You can see that these grains are longer grains. These columnar grains are long, and the size of that columnar grains, you can see that it is big grains as compared to these grains. Okay, these columnar grains are bigger in size as compared to these grains, and therefore here I am writing the long and coarse grain. Therefore, what is the correct option here? The correct option is here B and D. Okay, during the solidification of pure metal, grains at the center of casting is columnar grains, and guys, that columnar grains are longer and the coarse grain. Correct? And what about the randomly oriented grains, guys? At the border here, at the surface, you can see these are the randomly oriented grains. These are randomly oriented grains and fine equiaxed grains. These grains are fine equiaxed. Fine equiaxed means what? Equal axis in all side here. This is known as equiaxed. But where the equiaxed grains are there, equiaxed grains are there at the border or the boundary of the casting or at the surface of casting, we can say. And therefore, if they are asking at the surface of casting which type of grains are going to form, then randomly oriented grains which are fine equiaxed grains, that answer you can give. Yes, next question here, the question number 4 here. Which of the following are properties of molding sand? Okay. Which are the properties of molding sand? Guys, there are a number of properties of molding sand. The one property is the porosity is one of the property. Okay. The strength is also one of the property. Okay. The collapsibility is also property. Flowability is also property. But fluidity is not a property of molding sand. But fluidity is also property. But fluidity is the property of fluids, that is the liquids and gases, that is the fluidity is property. But for molding sand, the flowability is property. If instead of fluidity, if I am writing the flowability there, then all 4 options are correct. Okay, but here, how many options are correct? B is correct, C is correct, and D is also correct. The porosity, strength, collapsibility, again, any other property if you know, then you can tell me. Refractoriness is also one of the property, that are the property of molding sand. Okay. Now next is, yeah guys, one question is here. Yes, you try to read the question and try to write the given data. Then I am also going to solve here, but please read the question and try to write the given data here. Metal is to be poured in a cubical cavity of 100 centimeters side, made entirely in the drag. Here the cube we have to make whose size is 100. Therefore, here I can write the casting size. Metal is to be poured in a cubical cavity of 100 centimeter side. This metal is to be poured, we have to pour in a cubical cavity. Then if the cavity is cubical, then the casted component is also cubical. Therefore, I am writing here the casting size. Casting size. What is the formula of cube? Here the formula is A cube, and therefore here I am writing the 100 cube. This is the volume is 100 cube. Okay. Here also write centimeter cube. And entirely in the drag. Here I can show that it is in drag. Now just consider that this is the cubical cavity and it is entirely in the drag. This is the drag portion. Bottom one is drag, top one is the cope. Okay. The cross section of the cope box is 200 into 150 centimeter and height is the 100 centimeter. Here the height of this cope box is 100 centimeter. And the cross-sectional area of this cope box. Cross-sectional means we have to draw the 3D diagram. Then I need to draw that third dimension here. I need to draw the third dimension here. Okay. Okay, the third dimension here you can see. And that third dimension, what is the cross-sectional area? They given the 200 by 150 centimeter cross-sectional area of the cope box. 200 by 150. Then here I can write the 150. At the top horizontal distance is 200, which I can write here also. all dimensions, you need to remember that all the dimensions are in centimeter. All the dimensions are in centimeter. Okay. Then next, if the densities of the metal and sand are, density of molten metal is given, 7900 kilogram per meter cube, and density of sand means density of sand, okay, I am writing the sand, means density of sand mold here, it is 1600 kilogram per meter cube respectively. The minimum weight required to be placed on cope in kilonewton to prevent lifting of core box. Some new question, some different question is here. Guys, when we are pouring the molten metal and when this casting cavity is going to fill with the molten metal, then what happens? When it is totally filled, it will give the upward forces. It will give the upward forces, that is buoyancy forces it will apply here. You can see the buoyancy forces it is going to apply. And because of that buoyancy forces, what happen? Because of that buoyancy forces, what happen? Okay, that cope can lift, and we have to avoid the lifting of cope, and we have to avoid the lifting of cope. Then how we can avoid the lifting of cope here? And to avoid the lifting of cope here, we need to put some weight. Here we need to put some weight. And the what weight we need to put here to avoid the lifting of cope, that we have to calculate in this question. Okay. Then how to solve this? Okay. Firstly, guys, what is the formula for buoyancy force, or what is the unit of buoyancy force? The unit of buoyancy force is Newton. What is the unit of weight, guys? The unit of weight is also Newton. Then the formula remains same. Then first I want to use the formula for buoyancy force, that is in Newton, and also I will calculate the weight of cope, because the cope has also weight, na? And that formula for weight and buoyancy force, same formula I am going to use. But okay, then just see here. I want to write here the buoyancy force first. Buoyancy force, that is rho g a h. Now big question, the unit is the big question. What are the unit given here? You can see the dimensions are in given centimeter and densities are given in meter cube. Means either the centimeter we have to convert into the meter, or meter we have to convert into the centimeter. Any one thing we have to do it here. Okay. Okay, then here it is always better to convert the centimeter into meter. We can convert the centimeter into meter. How we can convert, guys? 1 meter is equal to 100 centimeter. Okay, 1 meter is equal to 100 centimeter. Therefore, the 1 centimeter is equal to 10 raised to minus 2 meter. Okay, 10 raised to minus 2 meter. Therefore, here it will be the only 2 into 1.5. Height will be the 1 meter. This is the 2 meter. 1.5 meter will be the all dimension. Understood? Okay. Then I am converting into meter. Then here the rho g h. Then now the buoyancy force I am going to calculate. Then buoyancy force rho. Rho is for molten metal. Molten metal is giving the net upward forces. Therefore, the rho of molten metal. Then what is the rho of molten metal? It is 7900. If I am not wrong, correct? 7900. What is the g is 9.81 meter per second square. What is the area into h? Area into h is the biggest question, guys. Area into h is volume. Volume of that casting cavity. Volume of that casting cavity. Then what is the volume of that casting cavity? Here I written the 100 cube centimeter cube, but that 100 we need to convert into meter. That is 1 cube is the answer. Volume is the 1 cube here. 7900 into 9.18 into 1 cube. Okay, give the answer first, then tell me the answer first here. Is this correct? Tell me. Tell me first, is this correct? Is this correct answer? 77,499. Please tell me first. If it is correct, guys, here final we have to give the answer in kilonewton. Kilonewton. Then I need to convert into kilonewton. Therefore, the buoyancy force is equal to, I am writing 77.499 into 10 raised to 3 Newton, and 10 raised to 3 Newton is kilonewton here. It is a kilonewton here. Okay. Then one case we completed. I hope so you also got the same answer here. Okay. One case is completed here. Okay. Now next is weight of the box here. Means scope of box. Weight of cope box. Formula is same, rho g h. Then what is the density of cope? 1600. G is 9.81. What is the area into height? That is the volume of cope. That is the volume of cope. That is the volume of cope. And what is the volume of cope here? Convert centimeter into meter. 1 meter, 1.5 meter, 2 meter. Very easy question. 1600 into 9.81. Volume of cope is 2 into 1.5. This 2 meter into 1.5 meter into the weight we have to calculate volume. 100 centimeter is height, that is 1. And is equal to, I got here 47,088 Newton. But we need to give the answer in kilonewton, that is 47.088 into 10 raised to 3 Newton. And 10 raised to 3 Newton is what here? The kilonewton. 10 raised to 3 Newton is what here? The kilonewton. Okay. Please solve this. Okay, give the answer. Yeah. Now see here, the final, what weight we have to keep there. Now what are the buoyancy forces? 77.49 in upward direction. Weight of the cope box in downward direction. Then weight of only 47, here it is a 77. Therefore, definitely the cope will lift because the buoyancy forces are more than weight of cope box. And therefore, what weight we need to put, what minimum weight we need to put, that is here you can see that minimum weight required to be placed, minimum weight is equal to here 77.49 minus of 47.088. Therefore, here the final answer is 30.41 kilonewton. This is the final answer. Okay, this is the final answer. I hope so you also got the same. Okay, complete this. Yes, now see the next. A cube and sphere of the same material cast under identical conditions, solidify at the same time. That is a clue to solve this question. That is the solidification time of cube is equal to solidification time of sphere. Great. Then ratio of length of cube to the diameter of the sphere is, length of cube to the diameter of the sphere is, okay, just calculate. Then here the solidification formula, that is what we have to calculate, ratio of length of cube to the diameter of the sphere. Means we have to calculate diameter of sphere, this one, L cube, length of cube, L cube divided by diameter of sphere, that answer we have to calculate. Okay, length of cube to the diameter of sphere. But guys, here for the cube, what we are taking for the cube here, the volume by surface area A cube we are taking, means length of the cube we are taking the A here, Therefore, it is the A cube divided by diameter of sphere. Just calculate here first. I am writing the solidification time of cube, that is volume by surface area of cube. Just solve here. Volume by surface area of cube, and here also the volume by surface area. Here I am writing the C for cube, and here I am writing the sphere. And what is the volume of cube? That is A cube, and surface area of cube, that is a 6a square, is equal to volume of sphere, that is 4 by 3 pi r cube, surface area 4 pi r square. Then how many terms are going to cancel here? This, and this and this, that is r by 3. Okay. Then here this get cancelled. Okay. Therefore, what is remaining here? The A by 6 is going on that side, then it is r by 3, that is 2r. Therefore, A is equal to 2r is diameter. Therefore, A by D is equal to 1. A by D is equal to 1. Therefore, what they asked here, length of cube, means only the length of cube, means A, we are taking the A is the length of cube here. Yes, to the diameter of the sphere. Then what is the correct answer here? The A by D is equal to 1. This is the correct answer. Small a is cube length. Okay, therefore A by D is equal to 1 is the correct answer. Okay, complete it please. Yeah, now here what is the casting question I want to take, that is completed. Now we have to start with the welding questions here. Okay, total 6 questions here we completed. Now see the welding question, that is question number 7. Which of the following joining processes are not homogeneous? Now this is also the tricky question. Which of the following joining processes are not homogeneous? There are the 2 methods are there. One is homogeneous and second is autogeneous. What is meaning by autogeneous? Autogeneous means no need to use the filler rod. No need to use the filler rod, that is autogeneous. But in homogeneous, we are using the filler rod here. Then guys, out of not homogeneous means it is autogeneous. Not homogeneous means it is the autogeneous. Then how many methods are there where we are not using filler rod or we are not supplying material? Guys, in the solid state welding, in the what I am saying, in the solid state welding, we are not supplying the molten metal, we are not using filler rod, and here you can see that the explosive welding and friction stir welding are the solid state welding. We are not supplying the extra material. Okay. Yes. Then here what is the correct answer here? The correct answer is A and D. A and D is the correct answer, because in MIG and in submerged arc welding we are supplying the material. Which material we are supplying? Same as the parent material. That material we are supplying with the help of electrode. Here the correct answer is A and D is the correct answer. Okay. Next question. Yes, again beautiful question of aluminum here. Aluminum is most difficult to weld. What is aluminum here? Aluminum is most difficult to weld because of following reasons. Aluminum is most difficult to weld because of following reasons. Okay. Then what is the first here? Low melting point temperature. Yes. Why guys the aluminum is most difficult to weld? What is melting point temperature of aluminum? If the MPT of aluminum, melting point temperature of aluminum is 660 degrees centigrade, and guys it is only the low melting point temperature. Guys, low melting point temperature materials as well as high melting point temperature materials are difficult to weld. and therefore guys, aluminum is most difficult to weld. One reason is low melting point temperature. One reason is here, low melting point temperature is also one of the reason here. Okay, next is low reactivity. Wrong. Aluminum has high reactivity. Aluminum has high reactivity. Aluminum has high reactivity. Aluminum has high reactivity because aluminum is highly reactive, everyone know. Because why it has high reactivity? When the molten metal of aluminum is producing, it is suddenly making the reaction with the atmospheric oxygen, and aluminum oxides are going to form, means some rust is going to form, some material properties are going to change, and therefore it has high reactivity. Low reactivity is the wrong. Okay, then low coefficient of thermal expansion, absolutely wrong. It has high coefficient of thermal, high alpha. It has high alpha, high coefficient of thermal expansion, guys. No one can tell the aluminum has low coefficient of thermal expansion. It has high value of thermal expansion, and that value is 23 into 10 raised to minus 6. 23 into 10 raised to minus 6. Okay, 23 into 10 raised to minus 6. Okay. Next is here the high thermal conductivity. Definitely correct. Aluminum has high thermal conductivity. It has the high thermal conductivity. Therefore, the both option here, the option A and D is correct. Aluminum is most difficult to weld because of the following reason. One is low melting point temperature. Second is high thermal conductivity. Third is high reactivity. Fourth is high coefficient of thermal expansion. These four parameters are there, and because of that the aluminum is most difficult to weld, guys. Okay. Now see here the next example here. Yeah, you read the example and try to solve here. You read the example and try to solve. Okay, very simple example is here. Yeah, solve here. During MIG welding operation, guys, what is meaning of MIG welding? It is one of the arc welding, and the long form is metal inert gas welding. During MIG welding operation, the electrode diameter used is 2 millimeter. Here I am writing the diameter of electrode here, guys. It is the 2 millimeter is the diameter of electrode. Wire feeder rate, guys. In the welding, the 2 points are there. One is a feeder rate and one is a welding speed. Okay, and you must differentiate that what is the feeder rate and what is the welding speed. Feeder rate means as you are flying the kite, you are supplying that rope, you are supplying continuously. Same way in the case of electrode also, if it is electrode, we need to supply that electrode continuously. That is the feeder rate. Then what the electrode they are, what the electrode, how the electrode they are supplying the electrode with the help of servo motor, and they are supplying the 3-meter length of electrode for 1 minute. Therefore, wire feeder rate is they are supplying the 3-meter length of electrode for 1 minute, guys. Okay. The next, the total area of weld bead is 31.4 millimeter square. This is the area of weld bead is equal to 31.4 millimeter square. Then the welding speed used in the welding process. Here we have to calculate the welding speed. Welding speed used in the welding process will be that we have to calculate and round off to 2 decimal places. NAT question, numerical answer type question, then how to solve. Okay. Is there any data missing or everything is correct, guys? Here you can see the everything is correct here, nothing is missing here. Okay. Now see here the melting rate of electrode. Melting rate of electrode means it is the discharge. And what is the formula for discharge? Discharge, that is the area into velocity. But for the electrode we are using the feed, area into feed. This is the melting rate of electrode is equal to what the melting rate of electrode, then that electrode is supplying molten metal. Guys, that type of question asked in GATE exam till 2 times is the same formula. Okay. Two times they ask the question. The melting rate of electrode means electrode is melting, and electrode is melting means electrode is supplying molten metal to the weld bead. Therefore, I can write the filling rate of weld bead. Filling rate of weld bead. Filling rate of weld bead is equal to what is filling rate of weld bead here? The area into velocity. Yes, filling. How the weld bead is going to fill? You can see that when the process is going on, when the filling process is going on, what is the welding speed here? Many student has confusion. What is the welding speed? Now see, this is the length direction, and electrode is moving in that, and it is supplying the molten metal, and electrode is moving. This speed of electrode, this speed, the electrode is moving slowly, 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 and it is supplying the molten metal, and that speed is known as welding speed, guys. And what is the feeder rate? Feeder rate means servo motor is supplying that electrode is known as feeder rate. Okay, you must know the difference between that. Then here I am writing the area of electrode. What is area of electrode? Cross sectional area of electrode, that is a pi by 4 d square into f here is equal to here the area of weld bead. This is the area of weld bead is given, and we have to calculate the welding speed here. Okay. Then here I am writing the pi by 4 into d square, then diameter square, that is a 2 square, into what is the feed is given 3 meter per minute. You need to concentrate on the unit. Here I am writing the diameter square, that is millimeter square, and feeder rate is meter per minute. Oh, meter per minute. Meter per minute, is this correct? Yeah, meter per minute. I'm writing here the meter per minute. Okay, into area of weld bead is 31.4 millimeter square into the welding speed. Here I am writing equal to 31.4 millimeter square into, I am writing here the welding speed. Okay, guys. Yeah, now see here, the millimeter get cancelled. We will get the welding speed in meter per minute. But what the answer we have to give? No man, we have to give the answer in millimeter per second welding speed. Then convert everything here in seconds. What is the feeder rate? 3 meter per minute. Convert 3000 millimeter, and 1 minute is what? 60 seconds. Convert it into, guys. Then here I am writing the 3000 by here the 60. Then here it will be the millimeter per second. Millimeter per second. Okay, millimeter per second. Okay, then calculate the answer. Then you will get the welding speed is exact. You will get the 5 millimeter per second. 5 millimeter per second. Exact answer you are going to obtain here. Okay, how nice question. Okay, complete it, please. Yes, next question. A power source characteristic of a DC power source. A power source characteristic of a DC power source is given by V is equal to, that is voltage is equal to I square minus 200 I minus of 4 volts. The current in ampere for maximum power is, here we have to calculate the current, guys. Here we have to calculate the current. Okay, then guys, we know the power is equal to V into I. Therefore, I am writing V is I square minus 200 I minus of 4 into of I cube minus 200 I square minus 4I. Okay, therefore here the For maximum power, what formula we can write for maximum power? For maximum power, what formula I can write? Derivative of power with respect to current is equal to 0. Why I am writing with respect to current? Because here you can see that the current is available in our equation of power. Therefore, derivative of this power with respect to current, that is I cube minus 200 I square minus of 4I is equal to 0. Then do the derivative here, 3I square minus derivative of I cube is 3I square, derivative of I square is 2I, that is 400I minus of 4 is equal to 0. Oh guys, how to calculate the I now? I got the tension how to calculate the I now. Now guys, this is known as some equation, this is known as some equation. What is this is known as? This is known as, guys, the quadratic equation, and we have one favorite formula for quadratic equation, minus b plus or minus in root b square minus of 4ac divided by 2a, divided by 2a. The same formula you apply. What is the ABC here? Now I am writing the a is equal to 3, a is equal to 3, b is equal to minus 400 and c is equal to minus 4. Do the calculation here, put it here, then I is equal to this formula. Therefore, minus b means it is minus 400 minus minus plus 400 plus or minus b square means minus 400 square minus of 4. AC, A is 3, C is minus 4, divided by 2 into A, 3 is equal to here the 400 plus or minus here minus 400 square means it is a plus 400 square divided by 6. You do the calculation, calci. I need to check if this correct. Minus 4 is C, minus 4 is correct, A is 3 and C is minus 4, correct. Here it is plus 48. Do the calculation. Here you will get the two values of I, one is positive and one is negative value. Then here the I positive value is, guys, 133.34 ampere. Okay, 133.34 ampere. And here the correct answer I is 133.34 ampere. This is the final answer. Okay, please complete this. You will get the two values. Try to solve both the value here. Yes, I hope so. You completed. Now see. Next, okay. Now the question of, guys, CNC machines. Question of CNC machine. For a 2-axis CNC machine, the slide along the vertical axis of the machine driven by a DC servo motor. For a 2-axis CNC machine, the slide along the vertical axis means the work table is going to move vertically. Okay. The slide along the vertical axis of the machine driven by DC servo motor. Which motor we are using, DC or AC? DC servo motor. Via gearbox and lead screw that mechanism with gear ratio output speed to the input speed is given by 1/4. Here the gear ratio is given 1/4. But I don't know either gear ratio is required or no, I don't know, but just it is given, then write down here the gear ratio 1/4. The lead screw has a pitch of 3 mm. Here you can see that the pitch, that is pitch P, is equal to 3 mm. The lead screw is fitted with the encoder. The basic length unit of the slide along the vertical axis of the machine is 0.02 BLU, 0.002 millimeter. Okay. When the axis moves along the vertical axis by 10 millimeter, what the distance traveled here? x distance traveled, and that x distance traveled is 10 millimeter. Okay. The corresponding number of pulses generated by encoder means when the axis moves along the vertical axis by 10 millimeter, the corresponding number of pulses means to travel a 10 millimeter distance along the vertical axis, what the number of pulses are required? Means here the x pulses we have to calculate, x pulses are required. Here the x pulses are required. Okay. Yeah. Then guys, for the here gear ratio is given, pitch is given, but one simple thing I want to tell you that what is the BLU? What is the BLU? When the machine control unit is giving one pulse to the motor, then the movement of work table is 0.002 millimeter. Means in one pulse, when machine control unit is giving one pulse to the motor, here which motor? Servo motor is there. Then the distance travelled by work table is 0.002 millimeter. Then how many pulses are required to travel a distance of 10 millimeter? Here even though the pitch and gearbox is there, gear ratio is given, but it is not required because you know in one pulse the distance travelled by work table is 0.002 millimeter. Then how many pulses are required to travel the 10 millimeter distance? Simple, do the multiplication here. 1 into 10 is equal to 0.002 into x pulses. And here the x pulses is equal to here the 10 divided by 0.002. Then x pulses is equal to 5000 pulses. 5000, yeah, 500 pulses here, the 5000 pulses, not 500, 5000 pulses. Do the calculation here. Here it is 1, 2, 3, 10 raised to minus 3. 5 into 10 raised to minus 3, 5 divided by 10 raised to minus 3 here. Then it will, minus 3 will go numerator, then 5 into 10 raised to 3. Then this is the 5 into 10 raised to 3, that is 5000 pulses is the correct answer. Okay, complete these guys. Yes, now take the next question here. What is the final here? The corresponding number of pulses generated by encoder means to travel a distance of 10 millimeter, how many pulses are required? Here the 5000 pulses are required. Next question, question number 12. A stepper motor drive having step angle of 7.2 degree per step. Means here the step angle means when the one pulse is given, then motor shaft is going to rotate by 7.2 degree. Then the distance travelled is known as BLU. Okay, that is simple. Then the distance travelled is known as BLU. A stepper motor drive having the step angle of 7.2 degree per step is when one pulse is given by the machine control unit to the motor, then the motor shaft is going to rotate by step angle, and that is 7.2 degree, and the distance travelled by work table is the BLU. Okay, is used for driving an axis in the NC machine. The motor is connected to the lead screw. Motor is connected to the lead screw through a gear having a gear ratio is 1/3. Here the gear ratio is given. 1/3 is the gear ratio. With the pitch of 3 millimeter, here the pitch is given, that is 3 millimeter. And the number of start is 2. Number of start is 2. That is n is equal to 2. What is the positional accuracy of the axis of the machine in microns? Positional accuracy means BLU we have to calculate. Now guys, here is a problem. We need to consider the gear ratio and pitches also. Now just see, in the 7.2 degree the distance travelled is BLU, that we know. Therefore I am writing here, in the 360 degree there is a one revolution of motor shaft. I am not writing. If you want to write, in the 360 degree there is a one revolution of motor shaft. One revolution of motor shaft then gear ratio into 1 revolution of lead screw. Here the gear ratio is given here, the gear ratio is given 1/3 into 1 revolution of lead screw means distance traveled is pitch or lead. Here 1/3 the distance traveled is lead. And what is lead? Lead is equal to N into pitch. N is what? Number of thread start. Number of thread start. Okay. Then what is the number of thread start? 2 here. Therefore 1/3 lead is equal to N into pitch. Pitch is 3. 3 get cancelled. Then you can see that in the 360 degree distance traveled is 2 millimeter. Then what is the step angle? 7.2 degree. Then in the 7.2 degree the distance traveled is BLU. That is BLU is also known as positional accuracy. Then what is the answer of BLU here, guys? 0.04 millimeter. But we have to write the answer in microns, means in micrometer we have to write. Then 1 millimeter is equal to 1000 micrometer. Then put here 1 millimeter is equal to 1000 micrometer. I am putting 1 millimeter is equal to 1000 micrometer. Therefore, the BLU is equal to 40 micrometer. That is BLU is equal to 40 micrometer. Okay. Completed. What they asked? They asked the positional accuracy of the machine in microns, and that is exact answer we got, 40 micrometer. Okay. Next question here. Okay, this is the question of water. This is the non-traditional machining method question we have to discuss. Which of the following methods are applicable for machining of ceramics? Guys, the ceramics is the brittle material, the glass is bitter material, and for that we are using the mechanical energy method, and that mechanical energy method is ultrasonic machining method. Definitely answer is also here. Ultrasonic machining method, the answer is also available. Okay. C is correct. Next, water jet machining. Guys, confusing question is here. Many students are telling that the water jet machining also can cut the glass material, ceramic material, but not possible. But when in that water we are going to add the abrasive, then it can cut. Therefore, the abrasive water jet machining is also correct answer. Guys, the water jet machining cannot cut the hard material because the water has very high softness. Whatever the with high velocity we are supplying the water onto the ceramic or glass, it cannot create the fracture, it cannot create the cut. Therefore, the water jet machining can be used for machining a very soft material such as rubber, plastic, food items. Food items means it can cut the non-veg. Okay. But water jet machining cannot cut the hard material. Okay. Then yeah, answer is completed. Answer is B and C. Answer is B and C. Okay, guys. The next question now. The electrode feed rate required. Here we have to calculate feed rate. Feed rate we have to calculate. Here it is given feed rate in millimeter per second. We have to calculate here feed rate in millimeter per second. The electrode feed rate required in electrochemical machining method is there. In a metal of atomic weight 56 here, atomic weight capital A, I am writing the 56. Density is 7.8 gram per centimeter cube. You must concentrate on the unit. Here it is given the centimeter cube, and final answer we have to calculate in millimeter per second. It means that the density centimeter we have to convert into millimeter, and I am converting. 1 centimeter is equal to 10 millimeter. And 1 centimeter cube is equal to, guys, 10 raised to 3 millimeter cube. Therefore, rho is equal to 7.8. 1 centimeter cube 10 raised to 3. When it will go in numerator, it is 10 raised to minus 3 gram per millimeter cube. Okay. and valence Z, and valence means valency Z. Z valency is denoted by Z is 2. With the specific resistance means rho R is given 0.5 ohm millimeter. The tool gap is 0.5 means L. Tool gap means gap between the tool and workpiece is 0.5 millimeter. Maintenance voltage is given, that is 18 volt, current is 500 ampere, and we have to calculate the feed rate. Here I am writing one wonderful formula for feed rate. Feed rate is equal to volumetric MRR divided by cross sectional area of the tool. Then calculate the volumetric MRR here. AI by rho ZF. AI by rho ZF. A we have, I we have, rho S, Z S, F S. Okay. All the points we know. Okay. Value of A, yes, 56. A we know, AI current, yes, current also we know, AI by rho S we know, Z also we know, and F is, that is fat is constant, always we can take 96,500 we can take always, then that all the values we have here. Then I am putting that all value is 56. It is little bit confusing for me here, but all the values we have. I is 500, rho is 7.8 into 10 raised to minus 3, Z is 2, and F is 96500. That value is given, that is we have the volumetric MRR. Great, we have the volumetric MRR. To calculate the feed rate, we must know the value of AC. Volumetric MRR, we can get it here, volumetric MRR. How to get the AC? Now this is a very big question, how to get the value of cross sectional area here. Now it is important to calculate us. Now see, I can write here the V is equal to IR, voltage is equal to I into R. Voltage we have here, the voltage is given here 18, and current is 500. Is the voltage is 18? Correct, 18, just check the data once. 18 volt, correct. This voltage is 18, current is 500 into of R. R is what? Resistance. And that resistance R is equal to rho R L by AC. Oh, now we are on the track. What is rho R? 0.5 ohm millimeter. What is the gap here? 0.5. Gap is also the 0.5 divided by AC. Okay. Then here, what is the R here? R is equal to 18 by 500. 18 by 500. Then R is 18 by 500. 0.5 into 0.5 by AC. Then here you will get the value of AC here. 6.95 millimeter square. Okay. You calculate, guys. Also calculate the value of volumetric MRR. It is 18.6 millimeter cube per second. Now put the value here in the feed rate formula. Then feed rate is equal to volumetric MRR, that is 18.6 divided by AC is 6.95. Therefore, here the feed rate (2.67 millimeter per second) is the feed rate. Yes. Yes, complete this question. This was the question number 14. Okay, I think only one question is remaining for us. Only one question. You complete this question. Yes, now see the last question here. Classroom practice question 15. This is the today's session last question. During electric discharge machining operation for drilling a square hole of 10 millimeter in a low carbon steel plate of 5 millimeter thick, okay, we have to produce the square hole in a steel plate of 5 millimeter thick. Brass tool and kerosene are used, okay. The resistance and capacitance of relaxation circuit are, I am writing the resistance is equal to 50 ohm and the capacitance, that is 10 microfarad, that is I am writing the 10 into 10 raised to minus 6 farad. The gap is maintained at such a value that the discharge take place at 150 volt. Okay, big value they given. Voltage is 150 volt. If the cycle time of the power supply is 0.7 millisecond, that is the cycle time is equal to 0.7 ms, that is millisecond, guys. It is not a second, it is millisecond. The average power input in kilowatt for the EDM process will be, here the power we have to calculate in kilowatt. Guys, the power formula, we can use the energy per spark. Energy per spark divided by time, Tc. Energy per spark is 1 by 2 CVD square divided by Tc cycle time. 1 by 2 into C is what? 10 into 10 raised to minus 6. Voltage is given 150. Guys, I need to check that value of voltage once here. Yes, voltage is 150, that is correct. Next is time is millisecond, 0.7 millisecond means we can write the 0.7 into 10 raised to minus 3 second. 0.7 into 10 raised to minus 3 second. Because 1 second is equal to 1000 millisecond. 1 second is 1000 millisecond. Then 1 millisecond is equal to 10 raised to minus 3 second. And here 1 millisecond is 10 raised to minus 3 second. Then here we got the answer for power. 160.71 watt. But here we have to give the power in kilowatt. Therefore, the power is equal to 0.16 kilowatt. This is the, guys, this is the answer of this question. And now with this question, today's my session is completed, and all the best for your exam. Thank you for attending this session.